Welcome to Breaking Changes TLDR, where we deviate from our normal weekly interview to focus on a specific topic, hopefully providing much more bite-sized segments for our subscribers to tune into. With Breaking Changes TLDR, we're looking to explore a diverse range of topics from across the world of APIs, but we're really hoping to break things down in ways that make APIs a little more accessible to a wider audience. Today, we're talking with Sanjay, Dalal, and Jayadeba, Jena about their recent submission of a draft with the IETF Network Working Group for an Idempotency-Key HTTP header field. Let's get to it. What is this idempotency header and why does it matter?
So the context-wise, this is not something new for HTTP APIs. It's just that different API developers use different things. So when I think in PayPal, when we were defining API guidelines way back maybe 2014, 15, we chose the name PayPal request ID for that. Previously, probably request ID was used. And I think around the same time, other vendors, other companies might have chosen different name. Like for example, Stripe might have chosen Idempotency-Key then. So fast forward when, it was last year, Jayadeba said that, we should try to standardize this. And I don't know, I never thought about that, but it was a very good suggestion. So we started researching at, what people are using. And Idempotency-Key kind of won there because a lot of FinTech companies are using that header name. Now I gave the context here, but I think what Idempotency-Key header is about, I'll let Jayadeba describe. I think he can describe it much better than I do.
Yeah, so I think to add to what Sanjay said, I'll add a few motivations on why we really did it. So the way back in like 2014, 2015, when we were designing APIs, so there were several ways that an engineer or an API team could implement idempotency. This is particularly about the unsafe methods in HTTP, like post, which is unsafe and modifies the state of the resource. And if you repeat that, it may lead to creating another resource. So developers, right, or various API teams implemented idempotency in many different ways. So what it became apparent was to the clients consuming many APIs from like same org, within or outside, right, that org, they had different ways of dealing with idempotency. Which led to bad developer experience. So consistency of idempotency behavior across APIs was a very important thing to address. The second thing was there was no declarative way of describing that a particular HTTP operation or API operation is idempotent. So it was not evident by looking at the Open API spec of an API and say, oh, this post operation is idempotent. So that declarative way was missing. So it was kind of a requirement to do that. So anyone without going much deep into the API docs, they can right away understand what this API operation is, whether it's idempotent or not. And the third thing was because there were like no common ways, right, to implement idempotency behavior, which means you cannot implement tools to handle or address that behavior in a consistent way. Like making use of the infrastructure to our advantage. So things like in case of failures, like for an idempotent method, a proxy can retry that, right? If it is an idempotent, it can safely retry without any side effect. So in order the proxy like API gateways, or you say on the client side, the proxies, in order to retry and retry confidently, right? It needed, a standard way of an idempotency implementation. So that's where we started creating that pattern in PayPal, and we implemented across our APIs in PayPal. And that's what Sanjay was describing. The PayPal request ID was the key, right? And the contract is so key is part of the idempotency contract. So key plus the payload, along with the payload, is the idempotency contract. So it helped us create, what we call default implementations, right? Sensible default implementations. So within PayPal, that many API teams could use, right? So it's not particular for PayPal, but anyone. When you have a standard way of doing it, you can create an implementation that you can use across your APIs at the edge layer, right? Which is at the API gateway layer, or at the service implementation layer where you are really implementing the API. So we did that, and our API is implemented in a consistent way. Our proxies, the gateways, right? All those can retry the request when there were failures, because it was clearly declarative from the specification. Right, that this is an idempotent method, so it is safe to retry. So when you onboard API to the gateway will also whitelist that API as an idempotent operation, right? So which meant it could retry the operation in case of intermediate failure. So it led us doing all these, a lot of this tooling in an automated fashion. Right, so these were the main drivers for that. And then we started, when we thought of making it a standard outside, and the STDPU API working group was forming newly. So we thought that's the right group, right, to add this proposal to. And we started looking at many other implementations. So naturally, there were implementation where there was a request ID, some in the body, there was header as request ID, and somewhere, some API, I think Alibaba, they have idempotency key in the request body. Then you say Adyen and Stripe, they had the idempotency key as a header. So again, they're all consistent. So we thought this is like, for a developer, if you think it that way, right, it's still cognitive overload, right? So it's not really portable. So sometimes it's in the header, sometimes in the body, right? A different way of implementing different even status codes on the behavior. So we looked at all of them, and came up with the pattern. I think that rightfully addresses this thing. And the key, of course, we thought idempotency key, the right name for the pattern. It is like very intuitive, right, for the name it presents. And request ID may be misinterpreted like for request tracking, right? Usually when you say request ID, it is like you can think of as like the idea of the request that you are using for some kind of tracking or distributed tracing or something of that sort. So in order to not to be ambiguous, I think we thought idempotency key is the right name for the header, and that's what the proposal is.
Yeah, and I think, when we were doing the looking at what other companies are using, right? If you choose something which is widely used, it's also could be widely, accepted. And request ID was one of the suggestions made before we made a proposal to IDF, that why can't we use request ID? But therefore, what we did was we listed all these implementations that we found in research, and that made the case that, okay, idempotency key seems like the rightly recognized name, right? And as Jayadeva was mentioning, a bit of historical aspect here I kind of skipped over. in enterprises earlier, when people were using APIs, often they had ability to define qualities of service like exactly once, right? In case of HTTP-based APIs, you don't have that liberty, and therefore the mutant methods, like mostly like post and patch, you do not have that. So you have to define something like this to protect those business operations. And what we found in our research was also that we have listed a lot of companies, which some of these Jayadeva mentioned. A lot of these are in fintech. Now, you don't want to do payment twice because there was some network error. It's a problem on both sides, sender and receiver, right? If you are doing a payment, you got an error, and you don't know what to do, you resubmit it, you are losing money twice, right? So we found a lot of fintech companies who are exposing APIs. They are using this header, and as Jaydev was saying, it's not the header only which is important. I think you have to relate it with the payload, which in the draft we are describing it as idempotency fingerprint. This is the name Jaydev came up with. Where you are creating some sort of a digest or a signature, or you're choosing which fields are important in the payload, and you're relating that with the value which is given in the header, so that on the server side, on the service side, you can determine that this is a duplicate request. You're not just looking at the header only, right? So that's very important, and we found so many implementations. So it made case right away to IETF Working Group that we should standardize it. There are few cases we have found, I think, which are non-fintech, but a lot of places we found fintech APIs require this, and if it becomes a standard, then it's everyone has consistent way of understanding what API offers.
So Sanjay also said two great points. So the one was like this header is not to be used for every HTTP operation. So put, delete, right, get, by default there are idempotent. So this header is specifically for non-idempotent operations, like the post or patch, where you can use. And the other thing was adding to the tooling support. So it is not just about retrying the request in the event of failures. It is also about your observability systems generating those alerts based on the failure condition you specify that is eligible for an alert within your org, right, which goes to your SRE team or whoever addressing those issues, and alerts for the other interested parties. Like you may have customers, right? So customers may be interested when there are like payment failures or something of that sort, which are like very critical to them. They want to understand at the end of the day why these payments are failing. So payments failing is like losing business, right? And it's critical. So many customers in the fintech business in particular, they are interested to understand or whenever there are failures, right, related to these core activities. So the observability system that you have, because it's declarative, and when you onboard the API, right, it goes live, you onboard to a gateway, onboard to the observability system, and that can detect those failures, right, and right away report to all the interested parties. So it addresses that entire set of ecosystem, how you implement a behavior, how you monitor, alert your idempotent APIs, right? And how do you, make your APIs reliable?
Well, it's clearly something that would benefit the entire industry. Well, I appreciate you both sharing this journey with me. I definitely learned something about the payment industry, and it helps me understand more about why API standards need to evolve. It's a very interesting look at how to continue to stabilize our collective online experience when it comes to the world of APIs. Thanks for joining us. You can subscribe to Breaking Changes TLDR segments or full Breaking Changes episodes on Amazon Music, Apple Podcasts, Spotify, and Google Podcasts. Or head over to postman.com/events/breaking-changes for more information.